Alright guys, so we're going to do a segment proof today. Okay, this is going to be example 1, so there's going to be a couple other videos that have examples in them if you need to go look those up. Okay, so we're first going to look and see what we're given here. So we're given that AB is congruent to CD. Okay, I'm just going to take a moment and I'm going to mark that congruency on my diagram. So AB is congruent to CD. Okay, and we're trying to prove segment AC is congruent to segment BD. Okay, so I'm going to highlight this AC is congruent to BD. Okay, y'all, that is what we are trying to prove. Okay, so remember, when you're doing a proof, it should be a logical progression. So that means that from one step to the next, or from one statement to the next, should have some kind of flow to it. It should lead into the next statement. Okay, remember, we always start off with our givens. So our given is AB, that's segment AB, is congruent to segment CD. Okay, our reason is it's given. Okay, so we can accept that as true. Okay, so since we've given a congruency statement, okay, automatically my brain is starting to think definition of congruency. Okay, remember, definition of congruency states that if two figures are congruent, then that means they're equal in size. Okay, so we can make a statement about the length of those segments. Okay, so the length of AB is equal to the length of CD. Okay, we can make that statement because of the definition of congruency. All right. Okay, so looking at this now, I don't have a whole lot to go off of based on the statements itself. But I can look back up at that diagram, and I'm looking at segment AC, so that's the yellow highlighted area, okay, and I see that AC is made up of segment AB and BC, and so my brain is automatically starting to think segment addition postulate. Okay, so segment addition postulate. So we can make the statement that AB plus BC is equal to AC, and then we can also make the statement about segment BD using the segment addition postulate. Okay, so we're going to go BC this time plus CD is equal to BD. Okay, and that's going to be the segment addition postulate. Okay, so that means we can accept that as true. Okay. Okay, so now what we're doing is I'm seeing, is there any way, okay, because remember, let me highlight this for us. Okay, we are trying to get that AC is congruent to BD. Okay, so now I'm starting to think, what can I do to those two statements of number 3, AB plus BC and BC plus CD? Is there anything I can do to those that will make them the same? Is there something that I can substitute in? Is there some kind of transitive property that I could use? Okay, so I'm looking back up at my second statement. AB is equal to CD. I see an AB right there. Okay, we already have BC and BC, So we just need to get that AB to turn into a CD, and then they'll be this exact same. So we're going to go ahead and substitute that in. Okay, so we're going to use statement 2 to do a substitution property so that we can get the left side of that equation to be the same. Okay, so in place of AB, I'm going to put CD plus BC equals AC. Okay, and now I'm going to go ahead and rewrite that little second equation that we had. BC plus CD is equal to BD. Okay, I'm doing that just because I like to keep everything together. That way I can see and I don't get myself confused. Okay, so now we have CD plus BC, and we have BC plus CD. Now remember, the order does not matter. Okay, so because these are equal to the same thing, oh, let me back up. Okay, we can do a transitive property. Okay, so remember, transitive property states that if you have two things that are equal to the same thing, okay, then they are equal to each other. Okay, so AC is equal to CD plus BC, and BD is equal to BC plus CD. That means they're equal to each other. So our fifth statement, okay, is going to be that AC is equal to BD. Okay, I forgot to write substitution. I got excited, got ahead of myself. That's our substitution property for number 4. Number 5 is our transitive property. Okay, because remember, AC and BD are equal to the same thing. So if they are equal to the same thing, then they're automatically going to be equal to each other. Okay, now we are really, really close to being done. Okay, I'm looking back up here. Okay, we have that segment AC is congruent to segment BD. Number 5 states the distance between AC is equal to the distance between BD. Okay, so we can do a definition of congruency. Because those are the same length, we can state that they are congruent. So segment AC is congruent to segment BD. Okay, and that's our definition of congruency. Okay, yeah, I hope this helped you. I will see you guys in the next one.